Hi guys, so the second assignment this week has to do with factoring polynomials, some of which I hope is review, but some of you have said before that you need more practice, so we're going to get some more practice. I would like to show you kind of the overview before we start. Zoom out on that a little bit more. Okay, so here's kind of your factoring guide. This is the last page of the notes. We also had a factoring flow chart that we've made that I think was on like pink paper maybe. So that might be helpful for you to look at. But the very first thing we always want to do is check for a GCF first. Okay, do that first. And then look and see if there's two terms. If it's a difference of squares, then we can factor it like this. If it's a sum or difference of cubes, then I'm going to talk to you today about some ways that we can factor those. And then otherwise, if we have three terms, then we can factor like we've done with quadratics. So you can do x factor, meaning find factors of c that add to give you b, then those are your factors. If the a value is greater than 1, then we want to find factors of a times c that add to give you b. And then we put those numbers in the box or in a group. Four terms, grouping, or you can do box if you like the box as well. Okay, so that'll make a little bit more sense here when we start going through. Yep, a little too big there. Okay, here we go. GCF. This is the first thing that we always want to look for. Okay, so the GCF, always look and see, what can both terms be divided by? The greatest common factor. Both my numbers can be divided by 2. Both the variables can be divided by a squared. We take that out in front. Then we think, okay, what is 12a cubed divided by 2a squared? That's 6a. What's 10a squared divided by 2a squared? That's 5. So those are our factors. Okay, because if we expand, distribute through, we should get back to the same thing. And that's a way you can always check yourself. Don't mind my 2-year-old. That's a way you can check yourself, is making sure when you multiply that you get back to the same number. Or sorry, same starting expression. Okay. All right, double check my math on number 2 with the GCFs. I think I pulled out the greatest GCF that you could and factor. Okay, difference of squares. This is where it gets a little bit interesting, but I'll be done in just a little bit, okay? Okay, and the next thing I talk about is difference of squares. Okay, so if we notice that there's two terms and that they're each perfect squares and that there is a difference between them, then what we can do is take the square root of each. So square root of a squared is a, square root of b squared is b. We put those in each set of terms, 1 plus, 1 minus. We've talked about before when we FOIL, to double check ourselves, a times b and then a times negative b, those two terms would cancel out. So we'd just be left with a squared minus b squared. Okay, so that's why it works going the other direction. Okay, so we've got here 9x squared, 49y squared, both perfect squares. Take the square root of each, 3x, and then 7y, 1 plus, 1 minus. Okay, some of these are a little more tricky because at first you're going to have to take out a GCF. So number 4, I'm taking out 2 first, and then I can see that 36c to the 4th minus 1, both of these are perfect squares. Now this gets a little trickier, so I'm going to separate it out. Square root of 36 is 6. Square root of c to the 4th is c squared. Okay, so I should have 6c squared as my first term in both parentheses. Square root of 1 is positive and negative 1 here that we're putting in, and that should be our factored form. Okay, I left a couple open for you to try if you'd like to. Okay, sum and difference of cubes. Perfect cubes. What you're looking for again is two terms, both the numbers being perfect cubes. And I have a process that we made up when I was in North Carolina in my first year of teaching because we were the Cumberland County schools, so the CCS was easy to remember. But it's a process that works really well because otherwise you just kind of are given this rule in math books and math websites, just kind of hope you figure it out. But the pattern should be that if you take the cubed root of the first term, meaning cubed root of a cubed should be a. Okay, that goes in my first set of parentheses. So we're talking about CCS is how we get the first set of parentheses. Then I take the cubed root of the second term. Cubed root of b cubed is b. And then I use the same side. So if I'm adding, I'm going to add here. This one I'm subtracting, so I subtract here. So same sign. Okay, that's how we get our first parentheses. Second set of parentheses, we use those results, meaning now I disregard the original problem and I'm just looking at what's in my CCS. Okay, so now I'm going to square the first term. Well, a squared is a squared. Then O is opposite sign. So if I was adding here, I'm now subtracting. Okay. Then I take first term times the second term. A times B is AB. Then A is for always add. Okay. And then I've got square the second term. So B squared is just B squared. So I'd like to talk you through a lot of these sum of cube problems. And then we'll talk through the formula for difference of cubes and a couple of those as well. So here we start out, CCS, okay, cubed root of x cubed is x. Cubed root of 27 is 3. Same sign, add. Okay, now that we have the CCS done, we're going to take a look at what we just got in those parentheses, and we're going to use the SOFAs. Okay, so for the SOFAs, we're going to do square the first term, we get x squared. O is opposite sign, so this is adding. So our sign needs to be opposite of that, which is subtracting. F stands for first times second, so I'm going to take x times 3, which is 3x. A is always add, and then the last S is square the second, so I'm going to take 3 squared, and that's 9. What's pretty crazy is if you expand this out, you should get back to the same thing. Okay. All right, number 8, let's talk through that one. CCS is our first set of parentheses. Cubed root of the first is m. Cubed root of the second, okay, 216, cubed root of that is 6, and cubed root of n cubed is n. Same sign, okay? Now we disregard the original problem, use that CCS to get our second set of parentheses. Square the first, m squared, opposite sign, subtract. Then we take first times second, so I wrote that as 6mn. Always add, square the second. So this whole term squared would be 36n squared. Hope that's kind of starting to make a little bit more sense, but we're going to talk through a few more just to make sure. Okay, number 9, I notice a GCF first. For both of these ones, I didn't talk about that because the GCF was just 1. This has a GCF of 4, and so does this. And they can each be divided by 4, which helps us out because 500 was not a perfect square, so this was going to get tricky otherwise. But when I divide both terms by 4, I get 125a cubed and 1, which are both perfect cubes. Okay, so cubed root of the first term is 5a, cubed root of 1 is 1, same sign. Okay, now I disregard everything and just pay attention to what's happening in that CCS, 5a plus 1. Square the first term, 25a squared, opposite sign is subtract. First term times second term is 5a, always add, and then square the second term, which is 1. I left one of the sum of cubes to practice so that you can kind of check and make sure you're on the right track. Difference of cubes, it's the same thing. CCS, so cubed root of the first, cubed root of the second, same sign. Okay? And then we disregard the original problem, look at what we were given. Square the first is a squared, opposite sign, now we are adding. First times second term, AB, always add, and then square the second term. Okay, on these examples, I kind of tried to pick the ones that were a little trickier. So 216k cubed minus 125, we're going to take the cubed roots of each of those terms. I should get 6k and 5, same sign. Okay, then I just look at my CCS, my parentheses here, square the first term, 36k squared. Then we do opposite sign, so add. First term times second term is 30k. Always add. And then 5 squared is 25. So the signs are taken care of by the O and the A in sofas. So when you're when you're squaring this term, disregard this sign. It's just the number, okay? And when you're multiplying 5 times 6k, we disregard that there's a 5 or a negative in front of the 5 right here. It's just k and 6 and 5 all multiplied together, just those terms, because we've already taken care that the sign is opposite. Okay. Number 14, there's a GCF. We're going to take out that 2, do the same thing we've been doing. Cubed root of the first term is x. Cubed root of the second term is 3y. Same sign, subtract. Okay. Then I'm going to square the first term, opposite sign. Then I take first times second term and I get 3xy. Always add and then square this whole term and I get 9y squared. I hope that's starting to make sense. Once you kind of get that formula down, that pattern down, things should be good to go. Okay, trinomials. Even though this isn't quadratic, all of these we have an a value of 1. Okay, so we're going to start there. This doesn't have a GCF, but it has n to the 4th, n squared, and then a constant, so it should work out really similar to quadratic. So we're going to take, factors of negative 24 that add to give us 2, because that's like our c and b values that we're used to doing. And that should be 6 and negative 4. Okay, double check, make sure you agree. 6 times negative 4 is negative 24. 6 plus negative 4 is 2. Then what happens is this term, if I am separating it out, should be n squared and n squared. N squared times n squared gives me n to the 4th. Okay, so then I have n squared plus 6 times n squared minus 4. And we think we're done, but wait, we're not. This is a difference of squares. So I got to take that one step further and separate that out and make it n plus 2 and minus 2, because both of these are perfect squares and there's a difference. All right, 17. I'm going to give you a couple to practice here, but number 17, take out a GCF, which is 2a, then I have a quadratic. Okay, trying to find factors of c that add to give us b. So factors of 34 that add to give us 19, I got 17 and 2. At that point, once I plug those in, I'm done. Okay, so 15 through 18 should all be kind of similar on this note sheet of what you're doing. Okay, number 19, a little more tricky. There's not a GCF, and this time the a value is not 1. So I want to find factors of a times c, which is negative 15, that add to give me 14. Okay, those numbers are 15 and negative 1, and then I put those numbers in the box. Okay, so we still write it the same way we would see it, 3x to the 4th, and negative 5 goes down here, and then we're separating this term into 2, so 15x squared minus x squared. I hope you agree with me that that is 14x squared. Then I'm going to factor up and left and take the signs of the boxes I'm factoring towards. So if I factor up here, what's in common is x squared. What's in common in the next column is 5. Okay, factoring to the left across the row, I should have 3x squared. And then negative 1, the reason it's negative is because I'm taking the sign of the box I'm factoring towards. So this is my final answer, 3x squared minus 1 times x squared plus 5 as factored form. If you don't like the box, remember, once we get to this point, you can do what we're going to talk about right now. Use grouping. Okay, group the first two terms, so you could have 3x to the 4th plus 15x squared grouped together, and then the last two terms, negative x squared minus 5, group those together. So for example, that's what I did here. Group my first two terms, my last two terms. This had a negative in between, so I just put a plus in between and moved the negative to the negative 4x. Okay, and then we're going to factor out the GCF for each group. In this first set of parentheses here in this example for 4 terms, I can take out an x squared, okay, and then I'm left with x plus 1. Here I'm going to take out a negative 4, so I have x plus 1. That's in common between the two, so I pull that out and I get x squared minus 4. Again, that's a difference of squares, so I need to factor further. Okay, so I'll let you take a look here for the last few seconds of the video, at factoring by grouping of my last couple examples. Good luck!